Here is the question. A slender rod of length L, diameter D, length far greater than diameter and thermal conductivity K1 is joined with another rod of identical dimensions but of thermal conductivity K2. So, both rods are having different thermal conductivities to form a composite cylindrical rod of length 2L. The heat transfer in the radial direction and contact resistance are negligible. The effective thermal conductivity of the composite rod is option A K1 plus K2, option B under root of K1 K2, option C 2 K1 K2 by K1 plus K2, option D K1 K2 by K1 plus K2. So here in the question it was given that the length is far greater than diameter. So therefore what we can do is we can consider the diameter is almost very less, and by considering the lengths of the figure we will be finding out the effective thermal conductivity of this composite rod. Also in the question he has given that the heat transfer in the radial direction is negligible and contact resistance is also negligible. So Q is negligible and contact resistance is also negligible. Now we need to determine the effective thermal conductivity of the composite rod. Now for that, so here the two rods are there. Let us consider this is rod 1 and this is rod 2. This rod is having thermal conductivity K1 and this rod is having thermal conductivity K2. Now both are having equal length. As diameter is negligible as compared to the length, I am not considering that part. So we need to find the thermal resistance of these rods. The total thermal resistance of this one will be equal to thermal resistance in the first rod plus thermal resistance in the second rod. Now thermal resistance in the first rod will be L by K1 into A plus thermal resistance in the second rod will be L by K2A. Now this is the total resistance. Now these two rods are replaced by a single rod which is having the length 2L. Now we need to find the equivalent thermal resistance for this one. So when these two are replaced, then the thermal resistance of this one will be 2L by K equivalent into A. So this is the thermal resistance of this one. As these two rods are replaced by a single rod, the thermal conductivity that we are going to consider here is the equivalent thermal conductivity. Now if these two rods must be replaced by a single rod, then the thermal resistance whatever is offered by these two rods must be same as the thermal resistance of this particular composite rod or composite ball. Now equating these two, we will get 2L by K equivalent into A is equal to L by K1A plus L by K2A. Now L by A can be taken common on the right hand side, then this will be 1 by K1 plus 1 by K2. Now L by A gets cancelled on either side. So therefore we have 2 by K equivalent is equal to 1 by K1 plus 1 by K2. Upon solving this, we will get K equivalent is equal to 2 K1 K2 by K1 plus K2. So the equivalent thermal conductivity of this composite rod is 2 K1 K2 by K1 plus K2. As this is a multiple choice question, option C will be correct for this particular question, and this is the end of the explanation for this particular question.